This is the video series on artificial intelligence in business. This video is the second part of the discussions on deep learning. I'm Ibrahim Kuşçu, the CEO of the Next Minds. In the first video of this discussion on deep learning, we have introduced the foundations of deep learning through some of the examples of conventional neural networks. We have introduced some of the key terms such as a neuron, such as connections as weights, such as learning algorithm, backpropagation, and we have also explained how learning occurs in a given artificial neural network. The first video on deep learning is very important as it forms a basis for this video where we will be discussing details of deep learning, and also we will differentiate how conventional learning methods are different than deep learning. Remember that the aim of a learning method is to be able to recognize the pattern, identify the rules that make up the data. This is easy and possible if you have a direct relationship between the values of input data and the required output. For example, in case of examples of logic gates, say OR, there is a direct relationship between two inputs and the required output. In the case of OR, if any of the input has a value of 1, the output will be 1, otherwise it will be 0. This is a very easy rule for the learning method to discover. Similarly, for AND function, if two input has the values of 1, the output will be 1, otherwise it will be 0. This rule also is very easy to discover because there is a direct relationship between the input data and the required output. But if we consider XOR, this function is a little bit more difficult because XOR doesn't refer to the direct relationship between the data, input data, and the output data. If you notice, it is not the values of the input that directly determines the values of the output. It is rather the relationship between the input values, that is to say, the equality, that determines the value of the output. In this case, it is a little bit more difficult for the learning algorithm to be able to discover this pattern or this rule that make up the input data. For large and complex data sets, it is almost unlikely that the input values will determine directly what the output value will be. So conventional learning methods will be weak, and therefore deep learning becomes, or deep neural networks becomes, essential and very important. In fact, one of the reasons why we have deep learning is because we are now dealing with large amounts of data, the big data. The big data, we have large rows of data, but also large features of data, that is, large dimensions. Conventionally, when there is a large amounts of data and large feature set, and the relationship between the input data and output data are not easily discoverable, the machine learning efforts would be directed to something called feature selection or dimensionality reduction. These works would be either done manually or it will be done automatically as a separate process. Deep learning comes into the scene here and creates almost a revolution in machine learning. Deep learning makes it possible to automatically discover useful features and also automatically reduce the dimensionality. In this way, not only a convenience is offered in removing the human intervention or making a separate learning mechanism for the feature selection and dimensionality reduction, but also the discovery of the pattern in the data has included discovery of the higher order relationship as well, so that the learning mechanism can create direct relationships between input data and the output data and make the learning mechanism an easier one to resolve. One of the important application areas of deep learning is for self-driving cars. Self-driving cars requires computer vision and image recognition. Often, image recognition requires handling complex and large amounts of data. And deep learning is very suitable for this. Let's now look at some of the examples. Imagine that self-driving cars are requiring to identify between motorcycles and other cars. In this case, the pictures or the video stream data from cars or motorcycles will be just large amounts of numbers of pixel data. These large amounts of pixel data will contain complex relationships. A deep learning mechanism will be successful on these because it will first look at the typical edges of the images. For example, for a car, it will look at how the window angle is, how the back end has some edges, and how the front has some edges, and the tire has some round edges. It will also look at the motorcycles, that the tires are almost similar to car tires, but a motorcycle has a handle and a long seat. So first, these edges, these lines will be discovered, and gradually deep neural network will be creating images of cars and motorcycles by looking at these early abstractions and how these early abstracted edges connect with each other and create a shape of a car or shape of a motorcycle. If this was done by conventional learning mechanisms, all this abstraction of the edges and how the edges are connected to each other, that information would be done manually or as a separate feature selection or feature detection process. So deep learning becomes a significant tool for the machine learning implementers to be able to solve large and complex problems. The result of deep learning, more complex problems than XOR or other complex problems such as image identification and labeling images have become possible. Let's now look at one of the most commonly used deep learning applications, that is face recognition. In recognizing the faces, again, deep learning mechanism will identify the edges on our faces. For example, the edges of our nose, edges of our mouth, edges of our eyes and eyelashes and the ears, and the general shape of our face. Similarly, the abstraction of the edges and how these edges are connected will be done for every element on our face, our nose, our mouth, and our ears. And then the location of each of these elements on a face will be determined by looking at the distances and the angles from each other. Then the deep learning mechanism will be able to identify a face when it sees a picture of it. Deep neural networks are not only good in identifying typical faces, but also in identifying exact face of a person. After it has been trained, a number of examples of the face pictures of a person. This is happening in social media, for example. The Facebook identifies us by looking at other examples of our faces. Some of the good applications of deep learning are in the areas of plant identification or in agriculture. In the plant identification, deep learning is used to identify if certain mushroom is poisonous or not. Deep learning looks at the color and the shape of the mushroom and predicts whether this mushroom can be eaten or not. Deep learning is sometimes used to identify certain plants and find out which group they belong to. Deep learning mechanism examines the pictures of certain plants and looks at their shape, color, and the patterns on the leaves of that plant, and then correctly predicts which group they should be belonging to. In agriculture, deep learning can help farmers to identify if their plants or trees have any diseases. Diseases are caused by harmful insects or weather conditions or any other external conditions. If there are any diseases on a plant, the leaves of those plants will change. Either the color will change or there will be some patterns on the leaves, probably made through the harmful insects. Well-trained deep neural networks on the pictures of leaves with diseases can be very helpful in this matter. Deep neural networks can identify whether a certain plant has a disease at the moment or will have one in the near future. This information can be very useful for the farmers to take any precautions and create healthy produces or crops. So far, we have described the differences between conventional neural networks and deep neural networks. And we also identified the significance why deep learning is so important in the current applications of artificial intelligence and machine learning. But how do they do that? How do they discover higher abstractions or higher level relationships in the input data so that the learning mechanism becomes simpler to identify the patterns or deep insights in the data? Discovery of such higher relationships or deep insights in the data is very important, because deep neural networks can come up with certain solutions that exist in our data that we could have never imagined, and that could be very useful in business applications. Now let's turn into examining deep neural networks and how do they make those high abstractions. Deep neural networks are essentially the same as the neural networks that we have studied in the first part of this video on deep learning. The difference is that the deep neural networks might have a large number of input neurons and large number of hidden layers, and each of these hidden layers might have large numbers of neurons. Apart from having large sets of neurons and connections and large numbers of hidden layers, deep neural networks might be using different mechanisms than backpropagation. Backpropagation is a very simple classical method, but deep neural networks uses different methods and most recent methods such as convolutional networks or deep reinforcement learning. Another important distinction between conventional neural networks and deep neural networks is that training the deep neural networks might take long time. It might sometimes take hours, days, and sometimes even weeks. Another important application areas of deep learning is game playing. Without providing any details about the domain or rules of the games, the deep learning mechanisms play the game against themselves and improve their performance over time. Perhaps this power of deep learning has enabled us creating intelligent artificial intelligence software that can beat human champions in chess or in the game of Go, like winning against the world champion Lee Sedol. Although we can differentiate between conventional learning mechanisms and deep learning mechanisms in terms of the power of the deep learning and the mechanisms involved in deep learning compared to the conventional learning methods, the approaches in the learning can be very similar to conventional learning approaches. Deep learning mechanisms again can use supervised learning scenario, unsupervised learning scenario, or reinforcement learning scenarios. In this video, we have presented a brief discussion on deep neural networks. We have compared and contrasted deep neural networks to conventional learning methods. We presented this in a very non-technical way. So we have omitted some of the commonly used techniques and tools in deep learning, such as convolutional neural networks and deep reinforcement learning. So, as an activity, please do a search on convolutional neural networks and find out the strength of the mechanisms that make convolutional neural networks so powerful in deep learning.